All righty, folks. So we're going to go ahead and finish off our analytical trig or analyzing trig essential skill today. And we're going to look at two different things, double angle and half angle formulas. There's other ones we could look at as far as like product of sum, sum of product, other things like that. But specifically, we want to look at the double angle formulas. So when we're talking about a double angle, it's basically 2 times the angle. In other words, an angle plus an angle. So the formulas we're looking at today are essentially formulas that come from the sum and difference formula. So sine u, again, sine, cosine, cosine, sine, and we end up getting essentially a double angle formula. So this first one is sine of 2u, or sine of 2 theta, equals 2 cosine theta. Actually, we usually will call it sine theta, cosine theta. So let me go and write that. 2 sine theta, cosine theta. And using our sum and difference down here, we get 3 different things for cosine 2 theta. So cosine 2 theta can be equal to cosine squared theta minus sine squared theta. Could be equal to 1 minus 2 sine squared theta. And it can also be equal to 2 cosine squared theta minus 1. And our last one we're going to look at is tan 2 theta. Tan 2 theta is essentially 2 tan theta over 1 minus tangent squared theta. And again, they come from the sum and difference formulas. So we have our different formulas here for the double angles for sine, cosine, and tangent. So we're just going to kind of just get familiar with these today. We're not going to do a lot with them. We're just going to kind of get familiar with some of these and see how we could possibly use these in some way, shape, or form. So let's take a look at this first one. It says, first of all, we have an angle. We know we're going to be somewhere between negative pi over 2 and positive pi over 2. So if we think about the unit circle here, negative pi over 2 is 3 pi over 2. And we have a positive pi over 2, which means we are not using this side over here. So this whole thing is going to be gone. So sine of u equals 7 over 25. So the positive sign, that'll be up in quadrant 1. So we're going to be over here somewhere. And we're going to bring this straight down here. And that means our u is going to be 7 over 25. So what we have to do is we're going to use our Pythagorean theorem to figure out what this other side is. And then we'll use our sum and difference formulas to figure these out. So to begin with, we need to figure out that x value. So x squared plus 7 squared equals 25 squared. So x squared plus 49 equals 625. So x squared equals 576. And then we're going to take the square root of both sides. So x equals a plus or minus 24. And then looking at where we're dealing with, We're on the positive side of the x-axis, so that's going to be a positive 24. So as we go through here, we're going to find sine 2u, cosine 2u, and tan 2u. So we're going to use our double angle formulas. So sine 2u, or 2 theta, or 2x, or whatever you want it to be. So sine 2u is going to be 2 sine u cosine u. Cosine 2u will be cosine squared u minus sine squared u. And tan 2u is going to be 2 tan u over 1 minus tan squared u. So using our triangle here, now we're going to just plug in our values based upon what we see. So let's do sine first. So 2 times sine of u, that's 7 over 25. Cosine u, that's going to be 24 over 25. And when we multiply straight across, we end up with 376 over 625. 14 times 24 is 376. All right, next up here, we got our cosine 2u. So cosine u is 24 over 25, so we're going to square that. Minus sine u, so that would be 7 over 25. We're going to square that. So 576 over 625 minus 49 over 625. And we're left with 527 over 625. And then tangent of 2u. So this is going to be 2 times 7 over 24 over 1 minus 7 over 24 squared. So 14 over 24. That's not a 24. So close to being 24. Over 1 minus 49 over 576. So get our common denominator here now. I'm going to multiply everything by 576. And when we cancel out there, let's see here, 24 goes into this 24 times. And we end up with 376, or I'm sorry, 336 all over 576 minus 49. And speaking of which, I just realized something. I had a multiplication error here. Should have been 336. All right, let's keep going here. And then we clean this up. And we end up with 336 over 527. So that's tangent of 2 theta. Now, notice, something we could have done here if we really wanted to. Tangent of 2 theta. Tangent is the same thing as sine over cosine. So another way you could have done this one is we could have taken the sine value, which was 336 over 625. And we could have divided it by the cosine value. And I'm okay if you guys do that. But for this video, I'm going to use the tangent formula just so we get practice at it. That way, in case I ever ask you to find sine without actually doing sine and cosine, you'll know how it works. So 336 over 527. So there's that way as well if you wanted to do sine 2 theta. So friends, you see the cosine u equals -7.9 over there. Why don't you guys go ahead and pause the video and see how you do with that, and then we'll come back and talk about it. All right, good luck. All right, well, let's see how we did on that one. First up, we need to go ahead and figure out where this angle is. So 0 to pi, here's 0, here's pi. That means I'm not using everything below. So we can go ahead and get rid of this. And cosine u equals -7.9. Well, cosine is going to be negative over here in the second quadrant. So here's my -7. Here's my u, and here's my 9. So we're going to have to go through and figure out what y is. So -7 squared plus y squared equals 9 squared. So 49 plus y squared equals 81. So y squared is 32. Y equals a plus or minus square root of 32. And looking at where y is at, we want the positive square root of 32. All right, friends, so we're going to go ahead and use our formulas here now. So sine 2u equals 2 sine theta cosine theta, or 2 sine u cosine u. Cosine squared u, or cosine 2u, that would be cosine squared u minus sine squared u. And tangent 2u would be 2 tangent u over 1 minus tangent squared u. All right, so let's plug these in again here. So 2 sine u cosine u, that's going to be 2 times sine u, root 32 over 9, times cosine u, which is -7 over 9. overall, that'll be negative 14 root 32. And I don't need to worry about changing root 32 to 4 root 2. It's not on the unit circle, so don't worry about simplifying. All righty. Let's try the next one. How about cosine squared u? Well, cosine will be negative 7 over 9 squared minus root 32 over 9 squared. So 49 over 81 minus 32 over 81. And all together, that would be 17 over 81. So I already know that tan 2u is going to be negative 1432, or negative 14 root 32 over 17. But using our tangent 2u formula, we're going to go ahead and figure that out here. So 2 times root 32 over negative 7. Just realized I never had a u at the end of that. And then 1 minus root 32 over negative 7 squared. So 2 root 32 over negative 7 all over 1 minus 32 over 49. So we're going to multiply everything by 49. And let's see here. That's going to leave me with negative 7 up here. These will cancel out. So all together then, friends, I end up with negative 14 root 32 over 49 minus 32. And lo and behold, friends, there's the answer we said we were going to have. Negative 14 root 32 over 17. All right. We're going to keep going here, friends. We got just a couple more problems here we're going to take a look at. What if we use these to now solve an equation? And then we'll use them to verify a proof. So why don't you go ahead and pause the video and see if you can actually use our double angle formulas to solve this next equation. All righty, let's see here. So 2 cosine x plus sine 2x equals 0. Well, friends, when I'm looking at this here, I see that sine 2x, and I think to myself, that's a double angle formula that I can use real quick. So I'm going to substitute 2 sine x cosine x in for it. Now we're going to go and do a little bit of algebra. So we're going to factor it out. And when I factor it out here, friends, I notice the common denominator is going to be 2 cosine x. And I'd be left with 1 plus sine x on the inside. So we set them equal to 0. So 2 cosine x equals 0. And 1 plus sine x equals 0. Which means cosine x equals 0. And sine x equals negative 1. So we ask ourselves, when is cosine x equal to 0? That happens at pi over 2. plus 2 pi n. And we are also going to end up with 3 pi over 2 plus 2 pi n. And then for sine x equals a -1, turns out that's also going to be 3 pi over 2 plus 2 pi n. So because that's a repeated one, because that is a repeated root, we don't need to write it twice. We can just go and drop that one. But what we do have to do is we have to link our roots to make sure to see if there's a way that we can write our answer cleaner. So let's see, we had pi over 2, and we had 3 pi over 2. And it turns out they actually are pi away, which you can kind of see that. So I can write this as a linked root. Instead of having 2 separate roots, we can write it as 1. So that means our final answer is going to be x equals pi over 2 plus pi n. Because these right here, friends, were indeed pi away. Pi and pi. All right, I want you guys to go and pause the video and see if you guys can't take a little crack at that. Take a crack at this trig proof and see what you guys can come up with. All right, good luck. All right, well, if I'm looking at this thing, first of all, I see this cosecant 2 theta. I see a double angle. That tells me that's probably the uglier side. I'm going to play with that. But I don't like cosecant because I don't have a double angle formula with cosecant. So I'm going to change that to 1 over sine. So I pick the side I want to play with. And now from there, sine 2 theta, that's going to be the same thing as 1 over 2 sine theta cosine theta. I'm going to do my double angle formula. And then all I have left to do is just take this sine theta, and I'm going to get rid of that by putting it up to the top, which would make it go back to being cosecant theta. So cosecant theta over 2 cosine, wrong color, 2 cosine theta over equals cosecant theta 2 cosine theta. And again, we have the correct same thing on both sides. So therefore, it is proven. So we can say we're done. All right, friends, we got one more problem left to take a look at, and then we will be done for the evening, and we'll talk more about this in the morning. So, half angle formulas. Now, a half angle formula, again, it's just a different type of formula, and these aren't really anything we get too terribly crazy with. But the biggest thing to remember is while we're dealing with the angle inside, notice how, see how we're dealing with the angle inside, the plus or minus is based off of where the half angle is located. So when we draw our angle out, it doesn't matter where we draw the angle. That's going to determine whether our radical is going to be plus or minus. The radical is going to be plus or minus based upon where the half angle is located. So let me show you what I'm talking about. I'm only going to do one of these here because these aren't a big deal. We don't ever use them in Calc AB, so we're not going to spend a whole lot of time walking through them. So let's take this first problem here. Cosine theta of 5 root 13. So first up, we're told that our angle is going to be located somewhere in between pi and 2 pi. So theta is somewhere between pi and 2 pi. So if I look at cosine, that means I'm not dealing with anything up here. Cosine is a positive value, so that means it has to be over here in quadrant 4. So over here in quadrant 4. So there's my angle, and I'm going to have 5 over 13. So that's my cosine. So I got to figure out the y value real quick. So 5 squared plus y squared equals 13 squared. So when we get that, we get 25 plus y squared equals 169. So y squared is 144. And y is going to be plus or minus 12. So if we're looking at where we're located, we're down in quadrant 4. That means I want y be equal to negative 12. Okay, so that's the triangle that I'm going to use to deal with my formulas. However, that's not the triangle or the angle that I'm going to be using to deal with my half angles. For the half angles, I got to do for my sign, for my plus or minus here, I have to deal with where this half angle is located. So let's see here. If theta is between pi and 2 pi, well, the half angle is going to be when I divide each thing by 2. Which means my half angle is going to be located somewhere between pi over 2 and pi. So a quick little gander at that here tells me here's pi over 2, and here's pi. So if my half angle is somewhere in here, and again, I don't know what that angle is, but if my half angle is somewhere over here, which means I can't be in quadrant 1, quadrant 3, 4, can't be in quadrant 3. So I'm between pi over 2 and pi for that half angle. This tells me that cosine over here is going to be a negative value. Sine over here is going to end up being a positive value. So when I go and take a look at those radicals, cosine I'm going to use the negative one, and sine I'm going to use the positive. So now we have our triangle that we're going to use for the formula, but we now know what sign to use for the plus or minus. So let's see how this works. So the half angle. So sine of theta over 2 equals plus or minus 1 minus cosine theta, all divided by 2. So if I'm in quadrant 2, that means my sign is going to be a positive value. So I'm going to use the positive radical. 1 minus cosine theta is going to be 5 over 13 divided by 2. So if I multiply everything by 13, I'm going to essentially multiply everything by 1. That ends up with the square root of 13 minus 5 over 26, which is the same thing as 8 over 26. And if I reduce that, I end up with 4 over 13. And I can break that radical up just a little bit. So square root of 4 over the square root of 13. And that'll be 2 root 13. What about if we tried cosine 2 theta? I'm sorry, cosine theta over 2. So let's try that. Again, we're going to use our formula here. So plus or minus the square root of 1 plus cosine theta divided by 2. So we think here about cosine. Over here in our half angle, it's going to be the negative. So I'm going to use the negative radical here. 1 plus cosine theta, again, that was 5/13. And we're going to divide it by 2. So multiply by 13, multiply by 13, and multiply by 13. So we're going to have a negative 13 plus 5 all over 26. So 18 over 26. And we can reduce that. That'll be 9 over 13. And when we plug that in there, friends, that's going to be root 9. Break that up a little bit over root 13. And that would be negative 3 over root 13. So I can already see that tangent is going to be sine over a cosine. So 2 over negative 3 is going to be tangent for the half angle. But again, I'm going to use the formulas for these just to make sure and to see how they work here. Notice I don't need to worry about plus or minus on the tangents. I can just go ahead and plug them in there. So say I use this first one here. So that means tan of theta over 2. That's going to be 1 minus cosine theta over sine theta. So let's plug everything in here. So 1 cosine theta, that'll be 5/13. And sine theta is negative 12 over 13. And if we multiply everything by 13, friends, we end up with 13 minus 5 over negative 12, which is 8 over negative 12. which is negative 2/3. But what if we would have used the other formula? In other words, what if we would have used this one? Would that have worked? Oh, one way to find out, we just plug it in. So tangent of theta over 2 equals sine theta over 1 plus cosine theta. Let's plug that in, see if it would have worked for that one. So sine theta, that was negative 12 over 13. 1 plus cosine theta, so 1 plus cosine theta, that'd be 5 over 13. And just like before, we'll go ahead and multiply out. And again, we're not going to spend much time with half angles. I just want anything, we just want you to be familiar with them and familiar with how the formulas work. We're not going to go crazy with them. The other things are the more important things. So negative 12 over 13 plus 5. So negative 12 over 18. And if I divide both top and bottom by 6, I end up with negative 2 over 3. There we go, folks. All right. So that was our double and half angle formula. So that takes care of the day. Like I said, I'll see you in the morning. We'll talk more about this. So good luck. Have a great night. Take care.